Hello, it's Epsilon Emerald. Welcome back to my channel. In today's video, we're going to be doing some maths. Of course, it is Pokemon related because, you know, my whole channel is Pokemon related. We're going to be talking about something that mathematicians refer to as the collector's problem. Now, as a collector of many things, but particularly Pokemon cards, this problem really appeals to me. But also I'm a huge fan of probability and statistics, so this problem is right up my street. So at the moment in the UK, McDonald's are doing this promotion where when you buy a Happy Meal, you get a Pokemon toy. Like this. And with the Pokemon toy, you get a card. Now, as far as I'm aware, the card that you get with the Pokemon does not, well, for a start, it doesn't match the Pokemon. As you can see, I don't have a Pikachu card. They don't match, but also I was told that they don't correspond to the Pokemon, so you won't always get a particular card with a particular Pokemon as like a pair. It could be that you get a Pikachu with this one, or you could get a Pikachu with this one, or etc. Now, I'm not really sure that that's true because out of the 6 Pokemon toys I got 6 unique cards, and the probability of that happening is actually very small if they are random. So I'm not sure that that is true, but for the purpose of this video and for the mathematics working out nicely for us, we are going to assume that whenever you buy a Pokemon toy from McDonald's, the card that you get with it is completely randomized. Okay? So, there are 12 different Pokemon cards you can get from McDonald's. And what I would like to know is, how many Happy Meals am I going to have to buy to get a full set of 12 cards? Because I'm not sure that eating that much fast food is good for anyone. So I want to know how many it is. Just take a moment, think to yourself, how many do you feel like it will be? How many, like on average, because of course it could be 12, it could be, infinitely many. Think to yourself, on average, how many Happy Meals do you think, intuitively, how many Happy Meals do you think I would need to buy to get a full set of 12 Pokemon cards? The answer might surprise you, but I don't know. So, let's do some maths. So, when I get my first Happy Meal, what is the probability that it's a card that I need? Well, it's 1, because I don't have any cards yet, so the probability that I get one I need is 1. Or let me rephrase it. How many Happy Meals, when I've had none so far, how many Happy Meals would I need, or would I expect to need, in order to get a card that I don't have? Clearly, I just need to buy 1 Happy Meal to get 1 toy that I need. Okay. Then, now that I've got 1 card, which could be this one, or it could be any of the other 11, now that I've got 1 of them, how many Happy Meals do I expect to have to need to buy to get another card that I need? Because I could buy a Happy Meal and get the same card. Or I could buy a Happy Meal and get a different card. How many would I expect to have to buy? Well, I think you're happy that it's probably 1 or 2. Closer to 1, you would think, because the probability of getting one I already have is quite rare. It's 1 out of 12. And the probability of getting one that I don't have is 11 out of 12. So you might be happy that I would need to really get 1, but if I'm unlucky, I'll have to get 2. But what exactly is that number? That's quite tricky. So instead of working that out, what we're actually going to do is start backwards, and then it will become obvious what that is. So think about this. I have 11 cards already, 11 unique cards. And now I just need that last card. Okay, when I buy a Happy Meal, what's the probability that I get that last card I need? Hopefully you agree that it is 1 out of 12. If I buy a Happy Meal, the probability that I get the one I need is 1 out of 12. Okay, so how many Happy Meals do I expect to have to buy to get the last card I need? How many would I need to buy so that I can expect, I might not, but I can expect to get the card I need? Hopefully you're thinking 12. Because if I bought 12 Happy Meals, in terms of probability, one of those should be, it might not be, it's probability, but one of those should be the card I need. So when I've already got 11 cards, on average, I need to buy 12 more Happy Meals in order to get my last card. Okay, let me add this to a list that I can keep running. So, to get the 12th card, I need to buy 12 Happy Meals. Okay, now let's think about going backwards one more step. Let's say I have 10 cards already. And I need 2 more. Okay, let's just focus on getting my 11th card. So what's the probability of getting one of the cards I need? So I'm going to buy a Happy Meal. What's the probability that that Happy Meal contains one of the cards I need? It's 2 out of 12. Because there's 12 possible cards, 2 of them are ones that I need. So, how many Happy Meals would I expect to have to buy in order to get a new card? Let me make it slightly easier. This fraction I can actually simplify to 1/6. So how many Happy Meals would I expect to have to buy so that one of them is a card I need? The answer is 6. Because if I buy 6 Happy Meals, probably one of them out of 6 is one that I need. So I would expect to need to buy on average, 6 more Happy Meals to get my 11th card. Let me add it. To get my 11th card, I would need 6. Okay, let's think about my 10th card. So let's say I have 9 cards already. And I need 3 more. So what's the probability of getting one of the cards I need as my 10th card? Well, I've got 9. There's 3 more I need, so the probability will be 3 out of 12. Which I can simplify to 1 out of 4. So, the expectancy. So, how many Happy Meals would I expect to have to buy so that I get one of the cards I need? Well, using the same logic as before, I would need 4 on average. Because if I buy 4 Happy Meals, probably one of those out of 4 will be a card I need. Okay, don't know if you can spot a pattern. You probably won't be able to spot the pattern if I write it in this format. If I write it in a different format, it's a lot easier to spot the pattern. Let's do one more, and then we'll try and extrapolate using the pattern. So, let's say I've got 8, and I need, how many? 4 more. So what's the probability on any random Happy Meal of getting a card that I need? Okay, so I need 4 out of 12. I could simplify that to a third. So I would expect to have to buy 3 Happy Meals. To get my 9th card. As you can see, getting your 9th card is quite easy, but getting your last card takes a long time. Sort of like me with my Shining Legends collection. Getting most of the hollows was really easy, but getting that last Latios hollow is for some reason really difficult. Okay. Let's look at one more, just because this is the one that's going to introduce some difficulty. Let's use a fresh sheet. Okay, so I have 7 cards now. So I need 5 more. Okay, so what's the probability of getting one of the cards I need? Well, that's going to be 5 out of 12. Which, by the way, I can't simplify, because 5 is a prime number. So, how many Happy Meals would I expect to have to buy to get one of those 5 cards that I need? Well, hopefully you're happy that if I bought 12 Happy Meals, I'd probably get 5 cards. Well, not 5 cards that I need, because some of those might be the same. But I'd get 5 cards that I don't already have. Yeah, some might be duplicates of themselves, but there'll be probably 5 cards I don't already have. Okay. So, but I just want 1. So if I bought 12, I'd probably get 5 that I need. But I just want 1 that I need. So, are you happy that if I bought 6 Happy Meals, which is half as many, I should kind of technically get 2.5 cards I need, because that's halved. So if I halve that, I should halve that as well. Okay, so how can I get to 1? 5 cards I need to 1 card I need. That's a fifth. That's dividing by 5. So I should need to get 12 divided by 5 Happy Meals. Okay, a fifth as many Happy Meals to get a fifth as many cards I need. I could write that as a decimal or as a fraction. I guess I'll write it as a decimal because we're talking about Happy Meals, and it's easier for you to picture. So I would need 2.4 Happy Meals. And because we're talking about averages, it doesn't matter that that's not a whole number. I mean, I know I can't go to McDonald's and say, can I have 2.4 Happy Meals, please? Okay, can I have 2 Happy Meals and then can I just have the chips of another Happy Meal? Like, no, you're not allowed to do that. But, it's an average, so it's okay. Okay. Now, we could keep going and we could keep using this method forever. Well, not forever. 7, 6, 5, 4, 3, 2, 1. But it would be nicer if I could spot the pattern and extrapolate it. It's not too easy spotting the pattern when the numbers are like this. But let me relate them to 12. If that makes sense. 12 is 12. Okay, I'll write it as 12. 6 is half of 12. So let me write it as half of 12. 4 is a third of 12. And 3 is a quarter of 12. And 2.4 is a fifth of 12. Suddenly there appears to be a pattern. I could write 12 as a oneth of 12. A oneth. The whole. Okay, a whole of 12th. I could write that. Okay. So now it becomes quite obvious that the 7th one is going to be a sixth of 12. Which is 2. And the 6th one is going to be 5, 6, 7th of 12, which is 7 twelfths. Oh my gosh. 7 twelfths, 12 sevenths. 1.71. I'll just call it that. Okay. So then the 5th one will be 12 divided by 8, which is 4/3, 1.33. Did I do that right? Is it 4/3? No, it's not 4/3, Emma. It's 3 halves. 3 halves. The sixth one, it's 12 divided by 9, and that's 4/3. Fifth, sixth, oh, what am I doing? Fourth, third, second. So this was the one I said at the beginning. We know it's like a little bit more than 1, but we're not really sure how much more than 1. Well, let's find out. 1.09. And the first toy, we already said we know that you only need to buy 1 box to guarantee getting a card that you need. But following the same pattern, this is going to be 12 out of 12. And I know that 12 divided by 12 is 1. So yeah, it works. So now all that's left to do is add all of these up. So, we've got 12 out of 1 plus 12 out of 2. The reason I'm adding them up as fractions is because it's more accurate that way. Well, it's not for the whole numbers, it doesn't make much difference, but this way I'm not going to forget any numbers as well. Okay, and that equals 37 point, let's say 0.24, it's rounded. So what we've just found out is that on average, okay, so the average person who's collecting these cards, the average Pokemon card collector will have to buy 37.24 Happy Meals in order to complete their set of cards. That is a lot of chicken nuggets. How many chicken nuggets do you get in a Happy Meal? Do you get 6? Let's times that by 6. That's 223 chicken nuggets that you're going to have to eat. That's a lot of processed chicken. I think we all agree it's worth it though. Okay, no. We don't agree that. How much does a Happy Meal cost these days? I think they're £2.70. So it's going to cost you £100 on average. £100.54p on average to complete this set of Pokemon cards. Oh dear. And that, kids, is why you shouldn't collect Pokemon cards. Yeah, I obviously am hoping that the fact that I haven't had any duplicates so far suggests that actually the McDonald's people have been very nice and made sure that you get a different card with different toys. So hopefully it's easy enough to get the ones you want. And remember that there's always trading if you have friends. You know, as you can tell by the content of this video, I don't have any friends. Because I just made a Pokemon Maths ASMR video, which tells you a lot about me. Anyway, I really hoped you enjoyed this video. It was quite fun to make. I do really like maths. I'm a maths teacher, and I do really like Pokemon cards, so it goes nicely together. In case you were wondering the level of maths that this is, I would say, I mean, this isn't examinable, in any of the GCSE or A-level maths that we do in the UK. It's not on any syllabus that I'm aware of, but it is interesting maths. And the idea of expectancy or expectation is something that comes up in A-level maths. So it might have been useful for your revision. I don't know, probably not. Anyway, thank you very much for watching, and I'll see you in my next video, which will be a traditional card opening ASMR video. Okay, bye.